Welcome back everyone, thanks for tuning in to another episode. In this video I will explain how to work with algebraic fractions. Some may call this the hardest paragraph in the whole chapter, but I'm here to prove them wrong. As long as you practice enough, everything will be just fine. So let's start the video and allow me to teach you something new about fractions. Before I'll throw any letters into the mix, let me first summarize the rules we had for fractions. If I had a fraction 10 over 15, I could simplify this fraction by dividing both the numerator and the denominator by the same number, in this case 5. This would give me 2 over 3. You could even say that 10 over 15 can be written as 2 times 5 over 3 times 5. Because both the top and the bottom have a factor of 5, we can erase them. The same goes for fractions with letters. In a fraction 3a over 4a, both the numerator and the denominator can be divided by a. This leaves me with 3 over 4. And in abc over bcd, we could even erase both the b and the c, leaving me with a over d. And the fraction 25ac over 5c can even be simplified into 5a. That's because both c's can be erased, and I can also divide both sides by 5. I then have the fraction 5a over 1, which is equal to 5a. That's the basis for simplifying fractions with letters. On to part 2 of the video, additions and subtractions. When we had the exercise 2 over 5 plus 1 over 5, we would add the 2 and the 1 and we would receive 3 over 5. So if I had the addition 2 over a plus 1 over a, I would receive 3 over a. And similarly, 7 over b minus 5 over b would become 2 over b. I could even place a letter in the numerator. 5a over b plus 2a over b would become 7a over b. So far, so good. The difficult part in adding and subtracting came into play when the denominators weren't the same. In 3 over 4 plus 1 over 5, we would first have to change the fractions so that the denominators would be the same. I would change them in 15 over 20 and 4 over 20, as 20 is the lowest common multiple of 4 and 5. And now I can just add the 15 and 4 to receive 19 over 20. With the introduction of letters, this rule doesn't change. The fractions 3 over a and 5 over b cannot be added. Yet, to make them equal, multiply the left fraction with b's and the right fraction with a's. This gives me the line 3b over ab plus 5a over ab. Now that they are the same, we can add them. The ab denominator stays the same, just like it always does. The numerator becomes 3b plus 5a. You heard me? 3b plus 5a, not 8ab. Do not make that mistake. To simplify 8 minus 2 over x, we first have to turn the 8 into the fraction 8 over 1. As the denominators are not equal, we have to change the fractions. By multiplying the 8 over 1 with x's, we receive 8x over x minus 2 over x. The denominators are the same, so we end up with 8x minus 2 over x. Let's do one hard one before we continue. Let's simplify x over 2 minus x plus 3 over 5. Just like before, we first have to change the denominators. The common denominator is 10, so I end up with 5x over 10 minus 2x plus 6 all over 10. Now that we've done that, we can subtract this fraction, which means I have to subtract 2x and I have to subtract the plus 6. So the correct answer is 3x minus 6 all over 10. For the final part of this paragraph, something easier, multiplying and dividing. Quick recap. 2 over 3 times 5 over 7 becomes 10 over 21. We just multiply the numerators and the denominators. And to solve 4 over 5 divided by 3 over 4, we multiply with the second fraction's reciprocal. So we get 4 over 5 times 4 over 3, which turns into 16 over 15, which again can be simplified into 1 over 15. For letters, it's just the same. X over y times 3 over b becomes 3x over by. 4 over a times x over 2b becomes 4x over 2ab, which can then be simplified into 2x over ab. And 3 over x divided by 5 over y first becomes 3 over x times y over 5, and then 3y over 5x. To simplify a minus 1 over 3 times a plus 5 over 2, we have to multiply the numerators as if they are a binomial. So we end up with a squared plus 5a minus 5 all over 6, which can then be simplified one last time by adding the like terms. A squared plus 4a minus 5 all over 6. And with that last big fraction gone, we've reached the end of this paragraph. I know there's a lot to unpack, so it's best for you to start practicing the exercises and get back to me when you have any questions. In the next episode, I will start on paragraph 1.4 and I will teach you how to work with powers. I hope to see you then. Bye bye!